Hello everyone, I am Ümit Alkuş. In this video, we will solve one problem in chapter 22. A total charge, negative Q, is distributed uniformly along a rod of length L. Determine the electric field at a point P whose x-coordinate is A, which is greater than L. Assume that at position X, there is a differential charge dq in a differential length dx. In order to find the electric field at point P, we assume that there is a positive test charge at this point. Because dq is also a negative charge, then the electric field at point P due to dq is drawn from P to dq. Therefore, the total electric field due to the rod at point P is calculated by the formula integral of dE negative I hat, because it is in the negative x direction. dE is calculated by the formula k times dq over r squared. Here, because k is constant, it can be taken outside the integral sign. So we are left with negative k times integral of dq over a minus x squared I hat. In order to calculate the integral, we have to find an expression for dq in terms of x. Since the line charge density of the rod is dq over dl, where dl is now dx, so we have dq equals lambda times dx. Also, since the charge is distributed uniformly, we have lambda as total charge Q over L. Here, we don't write negative Q, we insert the negativity of this charge to find the direction of the electric field. Therefore, dq becomes Q over L times dx. So, we insert this value into the integral sign. Therefore, we obtain negative k times integral Q over L over a minus x squared dx I hat. Q over L is constant, so it can be taken outside the integral sign. Therefore, we are left with negative k times Q over L times integral of dx over a minus x squared I hat. According to the figure, the limits of the integral is x equals 0 and x equals L. In order to calculate the integral, for simplicity, let us change the variable of the integral. So let us introduce a new variable u as a minus x. Therefore, the differential length du becomes negative dx. And the limits of the integral becomes u0 equals a and ul equals a minus l. Now we can calculate the integral. The electric field becomes negative k times q over l times integral of negative du over u squared I hat with the integral limits a and a minus l. Or simply k times q over l times integral of du over u squared I hat with the integral limits a and a minus l. Here we can use the integral of powered parameters. For example, integral of u to the nth power is u to n plus 1 over n plus 1. In our example, we can write the integral as u to negative 2 du. Therefore, the integral becomes negative 1 over u. Therefore, the electric field becomes k times q over l times negative 1 over u I hat. Now we obtain k times q over l times negative 1 over A minus L minus negative 1 over A I hat. The last term is calculated as negative L over A times A minus L. As a result, we obtain the electric field at point P as negative K times Q over A times A minus L I hat. Okay, this is the end of the discussion of this problem. Thank you for your attention. See you in the next video.